Another challenge you must tackle when using messaging is dealing with duplicate messages. Message brokers should ideally deliver each message only once, but guaranteeing exactly once messaging is usually too costly. Instead, most message brokers promise to deliver a message at least once. When the system is working normally, a message broker that guarantees at least once delivery will deliver each message only once. But a failure of a client, network, or message broker can result in a message being delivered multiple times. Let's say a client crashes after processing a message and updating its database, but before acknowledging the message. The message broker will deliver the acknowledged message again, either to that client when it restarts or to another replica of the client. Ideally, you should use a message broker that preserves ordering when redelivering messages. Imagine that the client processes an order created event followed by an order cancelled event for the same order, and that somehow the order created event wasn't acknowledged. The message broker should redeliver both the order created and order cancelled events. If it only redelivers the order created, the client may undo the canceling of the order. There are a couple of different ways to handle duplicate messages. One of them is writing idempotent message handlers. If the application logic that processes messages is idempotent, then duplicate messages are harmless. Application logic is idempotent if calling it multiple times with the same input values has no additional effect. For instance, canceling an already canceled order is an idempotent operation, so is creating an order with a client-supplied ID. An idempotent message handler can be safely executed multiple times, provided that the message broker preserves ordering when redelivering messages. Unfortunately, application logic is often not idempotent, or you may be using a message broker that doesn't preserve ordering when redelivering messages. Duplicates or out-of-order messages can cause bugs. In this situation, you must write message handlers that track messages and discard duplicate messages. Consider, for example, a message handler that authorizes a consumer credit card. It must authorize the card exactly once for each order. This example of application logic has a different effect each time it is invoked. If duplicate messages cause the message handler to execute this logic multiple times, the application would behave incorrectly. The message handler that executes this kind of application logic must become idempotent by detecting and discarding duplicate messages. A simple solution is for a message consumer to track the messages that it has processed using the message ID and discard any duplicates. It could, for example, store the message ID of each message that is consumed in a database table. When a consumer handles a message, it records the message ID in the database table as part of the transaction that creates and updates business entities. In this example, the consumer inserts a row containing the message ID into a processed messages table. If a message is a duplicate, the insert will fail and the consumer can discard the message. Another option is for a message handler to record message IDs in an application database instead of a dedicated table. This approach is particularly useful when using a NoSQL database that has a limited transactional model, so it doesn't support updating two tables as part of a database transaction.